Hey everyone, and welcome. Today we're going to tackle a topic that's frankly a huge dividing line between just writing code and being a professional software engineer. We're talking about encapsulation. If you really want to build Python code that's safe, reliable, and easy to maintain, this is a concept you absolutely have to nail down.
But before we get into the textbook definitions, let's just start with a simple question to get our heads in the right space. Imagine for a second, what if your data had absolutely no protection? What if any part of your code, anywhere, could just reach in and change a critical value with no rules, no checks, no nothing? Yeah, it sounds like total chaos, because it is.
I mean, look at this. A single, seemingly innocent line of code could cause an absolute disaster. Without any protection, someone could, either by accident or on purpose, set a bank account balance to a massive negative number. This one line is a gaping security hole, and it's the exact problem we're here to solve today with encapsulation.
So here's how we're going to break it all down. First, we'll look closer at the danger of this open code. Then we'll introduce the core idea of encapsulation. We'll see how Python handles it with its own unique rules. Then we'll level up from the manual way to the truly Pythonic way. And finally, we'll talk about the professional payoff, why this matters for your career.
All right, let's start with the danger of open code. That bank account example, that's not just some made-up problem. When your object's attributes are just out there, totally public by default, you have zero control. You can't enforce any rules, you can't validate any data coming in, and you're basically just hoping that nothing goes wrong. It's bad design, plain and simple.
So that brings us from the problem right to the solution, the principle of encapsulation. This is our main line of defense. It's a fundamental concept in object-oriented programming that was designed specifically to prevent the kind of chaos we just talked about.
So what is it exactly? Well, at its heart, encapsulation is really about two key things. First, it's about bundling. Packaging related data and the code that works on that data together into one neat little unit, an object. And second, and this is the really crucial part, it's about restricting direct access to some of that data, basically putting up a protective wall around it.
The perfect real-world analogy for this is an ATM. When you go to use one, you interact with it through a very specific, secure interface: the screen, the keypad, the card slot. You can't just pry open the machine and grab the cash or start editing the bank's database yourself, right? The machine controls your access and validates everything you do. That is encapsulation in a nutshell.
Okay, and this is a big one. We need to clear something up that trips up a lot of developers. Encapsulation is not the same thing as abstraction. Encapsulation is all about protection, hiding the data and controlling who gets to touch it. Abstraction, on the other hand, is about simplification, hiding all the messy, complex details behind a simple interface. Think of it like this. Encapsulation is what protects the car's engine, keeping all the complicated parts sealed away safely. Abstraction is the fact that you only need a steering wheel and two pedals to drive it.
All right, so that brings us to the practical part. How do we actually do this in Python? Well, this is where Python is a little different from languages like Java or C++. We don't have strict keywords like private or public. Instead, the Python community relies on naming conventions. Think of them as signals, or a kind of code of conduct from one developer to another about how an attribute is supposed to be used. And these conventions are actually pretty straightforward. If a variable name just looks normal, like name, it's public. Fair game for everyone. If it starts with a single underscore, like underscore name, that's the developer giving you a polite heads up, like, hey, this is for the object's internal use. You probably shouldn't be touching this from the outside. But then you have the double underscore name. This is a much stronger signal, and it actually tells Python to do something special to stop people from messing with it by accident.
And that special thing is called name mangling. It sounds complicated, but it's not. When Python sees an attribute that starts with two underscores inside a class, it automatically renames it behind the scenes. So our double underscore balance inside the bank account class secretly becomes underscore bank account double underscore balance. Now this is a real lifesaver when you get into inheritance, because if a child class also tried to create its own double underscore balance variable, it would get mangled differently, which prevents it from accidentally stomping all over the parent's private data.
Okay, so hiding data is just the first step. The real goal is to control access. So now we're going to look at the good way to do this, and then we're going to look at the professional, the truly Pythonic way. This is where you really start to separate yourself as a developer.
The good way, and you'll see this a lot, is to create manual getter and setter methods. So you'd have a method called get underscore balance to read the value, and another one called set underscore balance to change it. And this works. It's not wrong. Inside that setter, you can put your logic, like checking to make sure the balance isn't negative. It gives you control, for sure, but it can feel a little clunky, a little verbose. It just doesn't feel very Pythonic, you know?
And that leads us to a really important question that all great programmers ask. Just because something works, does that mean it's the best way to do it? In a language like Python, where we care so much about clean, readable, elegant code, is there a better way?
Oh, you bet there is. The professional, the truly Pythonic way is to use the @property decorator. This is the gold standard. Why? Because it gives you all the power and control of those manual getters and setters, but it does it with a clean, beautiful syntax that makes it look like you're just accessing the attribute directly. And here is the absolute magic of it. To the person using your class, the code looks simple and direct. Account.balance equals 500. It feels totally normal. But what's happening under the hood? Python is actually intercepting that call and automatically running your special setter method, the one with the @balance.setter decorator, where all of your important validation logic lives. It is literally the best of both worlds, a super clean interface with powerful, controlled logic hiding just underneath.
So let's bring it all home. Why does mastering this stuff actually make you a better, more hireable engineer? It's because when you use these tools correctly, you're showing that you think about the bigger picture, about code quality, about security, about making things easier to maintain in the long run. You're not just hacking something together to make it work.
And in the real world, this is a superpower. You can enforce business rules like, hey, an employee's salary can never be set below the company minimum. You prevent that nasty data corruption we saw earlier. You put all your validation logic in one single centralized place. And you protect your class so that other parts of the code, especially subclasses, can't accidentally break its internal state. Your code becomes tough, reliable, and robust.
So this brings us to a simple checklist for writing professional-grade Python. Use a single underscore for things that are meant for internal use. Use the double underscore to really protect critical data, especially from those inheritance conflicts. Always use @property when you need to control access to an attribute. Make sure you put your validation logic inside those setters. And here's the golden rule. Never expose the internal guts of your objects if you don't absolutely have to.
And hey, if you are ever in a job interview and you get asked about this right here, this is your golden ticket answer. Saying this shows that you don't just know a textbook definition. It proves you understand how it's done in Python, why it's done, and what tools you use to do it. It shows you think like a real engineer.
Because ultimately, every class you write, every line of code you commit, it tells a story about you as a developer. By using encapsulation the right way, you're choosing to tell a story of security, of control, and of true professional craftsmanship. So the only question left is, what story will your next piece of code tell?